Okay, so let's go ahead and do the second part of this lecture. So on bottom of page 66, now we are to the point where we can actually identify the outliers. Okay? So the way that you identify an outlier is this. An outlier, you can have an outlier that is on the high side and on the low side, right? So on the high side, if you are, when I do this, in other words, take the IQR, multiply it by 1.5, and you are greater than that distance away from Q3, you are an outlier, okay? So on the low side, it would be the other way around. On the low side, you would start from Q1, and you would subtract the 1.5 IQR. And if you're lower than that, you're on the low side IQR. Okay? So if you go to page 66, bottom, there's a green box. How to identify the outlier. Okay? So the magic number here that you need to know is the 1.5, obviously, and where you start from. On the high side, you start from Q3. On the low side, you start from Q1. Okay? And if you are higher or lower than that, you would be considered an outlier. Okay? Then flip the page, go to 68. It says making and interpreting a box plot. Okay? To do a whisker and box plot, you have to do the 5-number summary, which we already talked about. So you would do that, and you would make a box plot. So the box plot, I don't know if you guys know, the box plot looks like this, where you have the min, the max. Go ahead and label this. So you would have the min, you would have the max, you would have Q1, Q3, and this guy here in the middle would be your median. Okay? Because that's how you would, now obviously you would scale it out and it would be within scale, right? You would have to scale it to be correct. And that's how you would draw a box and whisker plot. Top of page 69, it says how to draw the box plot. Okay? So go ahead and read that. I'll wait till you're done reading that. Are there any questions on that? Are there any questions that you don't understand there? So you identify the outliers using the 1.5 times IQR rule. Draw and label the axis, scale the axis. We'll mark the median, draw the whiskers. Okay. So the point that is actually interesting for you here is, hang on a second, I'll be right back. There you go.
All right. I will give you that there. Awesome. Have a wonderful day.
You too. Okay, so the interesting point here, the point that you guys need to understand is how do you handle an outlier? What do you do with an outlier? Okay, you've identified it as an outlier. You know it's going to skew your distribution all over the place. Okay, so what do you do with it? So the answer is you discard it. You do not use it. Okay, so let's go through the example on page 69 where it says picking pumpkins. Some students purchased pumpkins for a carving contest. And so they have all that data. A, make a box plot of the data. Okay, so let's make a box plot of data. They found the median, the Q3, the Q1, and the max. They did the IQR. IQR turned out to be 8.7, and they calculated a high outlier threshold to be 25.75. The negative one to be, the lower one to be negative 9.05. So obviously you're not going to have any low outliers because pumpkins do not weigh negative numbers. But on the high end, you have 25.75. If you look at there, you have a 31 and a 33. So those two numbers are outliers, okay? So if you flip the page, look at the box plot that is drawn, you can see the two asterisks there that signify the 31 and the 33 that you have dropped and you did not use. That's why if you look at the box plot, the maximum number is no longer 33 or 31. It is the number that's the highest number besides the 31 and the 33, which would be 15. So 15 becomes your maximum number. On B, explain why the median and the IQR would be a better choice for summarizing the center and the variability. Okay, so why would it be? Because you have two outliers. And if you have the outliers would significantly affect the mean because the mean is not resistant to outliers. The median and the IQR are going to be resistant to the two outliers that you have, okay? And that's why you would use those. Okay, so that's that. On page 70 in the middle, there's a red button there. Box plots do not display each individual value in a distribution. And box plots don't show gaps, clusters, or peaks. So this is one of the bad things or things that the box and whisker plot lacks. Okay? Comparing the distribution with box plots, you would just compare the same thing, right? You would compare the outliers, the centers, the variability, and the shape, right? The socks, the same socks that you did before, right? Okay, you would, again, when you're comparing two distributions, you have to compare using the socks, right? And it's the same thing when you're comparing box plots. You would still use those four criteria to make the comparison. Okay, if you go to page 73, looks like you can do a box and whisker plot using your calculator. Okay, so it shows you how to do that. I would definitely kind of invest in this and see how you do that, so you know how to do that. That's it, we're done with 1.3. So let's go back to page 54. So let's open back up to page 54. Let's go through the learning targets, make sure we know what we are supposed to know here. So the first one says, calculate the measures of center, the mean, median, for a distribution of quantitative data. How would you calculate the mean? Caden, how do you calculate the mean?
You get the average.
Yeah, you add them all up and divide it by the number of points. Okay, how do you calculate the median? Allison, how would you calculate the median?
You would line all the numbers up and then count to the middle number.
Yeah, you count towards the middle number, right? So you go from the smallest to the largest and you would count in towards the middle, right? That's how you do the median. Okay, that's good. The second point is calculate and interpret the measures of variability, the range, standard deviation, and IQR. Okay, so Kyle, how would you calculate the range?
The minimum and the maximum. So
Right.
you just subtract the minimum from the maximum.
Correct. There you go. That's how you calculate the range. Good job. Standard deviation. Lauren, how would you calculate the standard deviation? If I gave you 20 numbers and I told you to get, I want to know what the standard deviation is, how would you find it?
It's just the number and you'd minus the mean and you'd square it divided by n minus 1 and the square root of it.
Well, you'd have to do that 20 times, right? If you wanted to do it.
Yeah.
That way. That's not what you would do, right? How would you find the standard deviation?
Just plug it into your calculator.
And do what?
What do you mean? Just use the formula in your calculator?
No. That's not how you do it. You go ahead and put in your calculator, you would populate L1, that's all 20 of the L1s, and then you would do the 1-var stat test, right?
Oh, okay.
That's what I was trying to get you to say. The 1-var stat test will give me the standard deviation, okay? So you're not actually calculating anything. You're just inputting the numbers. The calculator does it for you, okay? Okay, let's see. Cat. I haven't picked on Cat yet today. So how do I calculate the IQR, Cat?
The IQR is the third quartile minus the first quartile.
Okay, it's Q3 minus Q1, right? That's how you calculate the IQR. And why do I need to know what the IQR is?
So that we can determine outliers.
Correct. That's one thing, all right? That's one thing that we would use. We need to use that to find the IQ, to find the outliers, right? And the outliers, what is the number, the magic number that I use for IQRs, for the outliers?
1.5.
Mm-hmm. Correct, 1.5. And you would measure from Q3 if you are 1.5 IQR above, or from Q1 if you are 1.5 IQR below that. That would be your threshold for outliers. Okay. So that's good. So Mackenzie, what do I do with outliers when I'm doing a lot like a box and whisker plot?
Well, you have to find the IQR or whatever to eliminate the outliers.
Okay, so you would eliminate the outliers. That's what you would do, right? You would eliminate the outliers, right? Okay, so that's what you would do with the outliers. So blah, 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 blah. Explain how outliers and skewness affect the measures of center and variability. Okay, so the center gets pulled, or the mean gets pulled towards the skewed side, right? And also, what happens to the median? How does the outliers affect the median? Lauren? It's a trick question.
The median is resistant, so it doesn't really affect it.
Yes, exactly. So it does not get affected, right? Good. Make and interpret box plots of quantitative data. Okay, the 5 points are the minimum, Q1, then you have the median, Q3, and the max, right? So the 5 numbers for our box and whisker plot, the 5 number summaries. The very last one says, use box plots and numerical summaries to compare distributions of quantitative data. What are the 4 criteria that you have to specifically address when you're comparing the 2 distributions? Claire.
The shape, outliers, the center, and the spread.
Correct. SOCS, right? SOCS. Okay. So